Here we go. So what's the first step for this? So what did we do last time for this question? The first step is going to be which? Yes. So what we're going to do, okay, guys, stay with me here, please. Thank you. Derek, we'll try to change the 2 into then.
Into an expression of log.
Good. Any guess what that would be?
Log 100.
Log 100. Now I'm going to write it as this. But 100 is correct. Okay. But the reason where the 100 comes from is right there. That's where it comes from. Okay. 10 squared is 100. So that's going to be log of 3x squared minus 9 equals log of 100. Yeah, Chris?
And so then you would cancel out the logs.
Yes.
Yeah, Chris.
Yeah.
Do we have to show the expression of log, or can we just go straight to 3x squared minus 9 equals?
Probably you can go right from 3x squared minus 9 equals 100. Okay, but I just want to show you why it is, because if I don't put this step, people are going to say what just happened. If I don't put this step, people are going to say what just happened. Okay, so you guys are calculoids, though, which meaning that you're pros at math. Okay? Nicole, v squared, what is the next step to solve for x, please? Isolate. Okay, so I'm going to add 9, so it's going to be 3x squared equals 109. Oh, this is going to be a mess. X squared, yeah, leave it in radical form, I think.
Really? We shouldn't do decimal root? I like.
Okay, now Chris, just when you get to University of Toronto, first of all, when you come back next semester, like in March, I want to see you come to my calculus class if I'm teaching it, and I want you to do a little speech to them, and I want you to tell them if they use calculators or not in university.
Okay.
Okay, because as I keep saying, guys, please, there's a 50-50 chance if you will or you won't, or they'll say you all get to use this calculator, it'll be the simplest, easiest, smallest calculator that you can get. Okay, so just get in the habit of doing this to leave it in the square root, because that's what we expect to leave it, and that'll be right. Okay? If you give me the decimal on your test, it'll still be correct. Okay, but we're looking to save a little time here. Okay, are we feeling sort of okay about this? Okay, I'm going to start to do a big giant note with the laws, the logarithms, and list them all out for you right now. Okay, so probably some of these you'll know, some of these you might not have remembered. Okay, but they're all going to be listed right now. Actually, let's just go before. We'll do one more example here. Okay, can we do this, guys, please? Here we go. Let's change this into exponential form first of all, because I want to make sure we know what logarithms are all about. Because logarithms are the opposite of the inverse of exponential. What's that in exponential form? Is that a stretch or a hand? That's a hand? Yeah, go ahead. Good. Those two things mean exactly the same thing. Okay, and that's the whole idea about logarithms. With logarithms, what we did is, again, you bring the log 6. So again, the other way to think about it, if you take log 6 of 6, that'll disappear and the x will come down, equals log 6 to the 12. Okay, so let's go through all our laws here. Here we go. Number 1. What does log a to the power 1 equal? Let's convert it over first. What is that in exponential form? Yeah, go ahead.
That's a good question.
Yeah, go ahead.
We'll always cancel it for these questions.
What do you mean? Sorry?
Like with log on both sides.
Yeah, totally, yeah. Sorry. It is equal to 0, y is equal to 0. Good. So what this means is a to the 0 equals 1. That means the same thing as this. Okay? Now, these facts are things you're going to need to know, because when we take derivatives and stuff soon, and you get an answer of log 2 to the 1, you can just cross that out. Okay, right? These are the types of things we're going to have to get used to. Step number 2. log a to the x. Now, we've used this one quite a bit, okay, without even sort of mentioning it. Log a to the x. Okay, well, let's do it the other way here first. What is this in exponential form?
It would just be
It would just equal x. Okay, that's what this equals. Okay, so this would be a to the x. No, let's go here. We'll just leave that for right now. Number 3 is a to the log a to the x. Again, just equals x. And my example for this one would be like 6. Oops. 6 log 6 to the 3. Okay, is equal to x. Okay, just go down a little bit so you guys can see. Okay, let's use some algebra to solve this one.
Are those like two separate things?
Yeah, we're just going to see what it solves here. It is going to equal 3. It's what it's going to be, but I'm just going to show you why it is. Okay. Okay, so how are we going to solve this one? Yeah, go ahead. Yeah, go ahead.
Would it be 10 to the x equals log ax?
10 to the x equals what?
Log ax.
Sort of.
Well,
Let's just take the log. Let's just take the log of everything here, okay? So log to the 6 of log 6, 3 equals log. Okay, what happened here? Do you need to show more work on it, or is that okay? I'm going to show another step. Hold on. I'll show another step then. Okay, so what this turns into, I'm going to take the log 6 of everything. Okay. Now, using my power rule, what does the left-hand side turn into? No, let's just use our power rule on the left-hand side. So that's going to be log 6, well, log 6 to the 3, which is going to come down, right? Using our power rules then, what log 6 to the 6 going to equal? 1, right? Now this stuff is a little counterintuitive. It's like exponents, right? When you learn those, it's counterintuitive. It's a little bit backwards, but you got to think of it. Does that make sense?
You do put the other one, like the a log
Yeah.
x thing.
Yeah. Let's do example 2. Oh, sorry, I'll move that up. Okay, so for number 2, let's do that up here.
No, like number 3. Like the 3, but like.
Oh,
not
just in
three.
general?
Yeah.
Oh, okay. Okay, so it's going to be a log a to the x. Equals x. Okay, so I'm just going to take log a of both sides. then log a to the x equals log a to the x. So x equals x. I don't know. That's all. I just proved x equals x, right? That's all I did there.
Where's the log AA go?
Oh, because log a just equals 1. If you change this to exponential form, right, this means that means, sorry, so anything.
Okay, just like 10 and 10.
Yeah, right on.
Okay.
Sorry about that. I sure wrote that. Sorry, that's what you were missing there. Log anything to the same power as 1. Yeah.
Okay, so for the one before,
Yeah. This here, you mean?
yeah, I can get to the point where it's like, oh, you put the log 6 on both sides, but
Yeah.
it's still the same.
Yes.
And then you drop down the exponent.
Yes.
But what my question is that where does the log 6 go?
Right here. It goes right here. Log of anything, just in exponential form, it just means that this means that a to the 1 equals a, which it is.
Wait,
So any log to the same that has the base and the number that are the same just cancels out, it just equals 1.
but then you kept it on the right side.
Well, because log 6 to the x, we still have there, right? I'm just dropping log 6 to the 6. If I were to say log 30 to the 30 is equal to 1. Log 2 to the 2 is equal to 1.
Okay, yeah.
You know what I mean? Like anything with the same number in the subscript is going to be the same when equal 1. Luke, how are you feeling about this?
Is that just like number 2, like log a to the a is equal 1?
Right on.
Okay.
Sorry, Mike had a question?
What's it all about? Yeah.
Logarithms is what it's all about. It's all about
I
logarithms.
don't really get what you're doing.
Okay, which part? I'm just proving this. I'm just showing you all the rules of logarithms. Because we were solving equations before, but I'm showing you why all the cheats that I used actually work. That's what I'm showing you right now. So if you ever see log 2 to the 1, that just equals 0. If you see log 5 to the power 10, that, yeah, or whatever, it equals, yeah, log a, so 5 to the power 10 would just equal 10. If you were to, say like 3 to the power log 3x, it just equal x. That's what I'm showing you, right? Just in general, when you see these things, you can use the shortcut directly. And this is just sort of the reasoning why the justification on the right-hand side. That's all it is. You don't have to memorize these 1, 2, and 3 you need to memorize if you don't have them for advanced functions already. Okay. I'm not going there. Okay, but you should probably, you guys did go through this a lot in advanced functions, I'm assuming, right? You spent like weeks and weeks and weeks on this stuff? Or 2 weeks probably. 2 weeks. Okay, are we done? Can I slide ahead here? Mike, are you done with the left-hand board? Okay. Let's go on to number 4. No, sorry. Actually, let's call these the 3 laws of logarithms. Sorry for number 4. Okay, number 1 is the product law. Okay, this is one we used. We used the quotient one already. Okay, but the idea is if you have 2 things multiplied together, you can go back and forth, okay, like that. So as you can imagine, we're going to be taking the derivative of this, right, very soon. Okay, so just getting into the idea of you can spread them apart or keep them together, it both works the same way. Yes?
Are we going to be doing this first?
No. Not for this stuff, no. Like, I'll tell you anything that you have to prove, but no, these are, you're supposed to already know. Okay? No. You should have already known, like, done all this last semester. Number 2 is the quotient law, which is log A, and we already used this one today. And this is just like exponents, right? The same way exponents work, the same laws happen. And my last one, and then we're done, is my power law. I should probably change your base to, it's not written on here. Again, we've used this one a lot too, the power law. The fourth one I'm going to do is the change of base, even though it's not really a law of logarithms. If you're looking to calculate things out on your calculator, you can calculate it like that. Okay? And now I'm just going to do some examples and hopefully get to the letter E today, or the number E, if I can have enough time. So hopefully all this stuff is somewhat coming back to you a little bit. I know this is fast and furious. I know you did this for 2 weeks last semester, so last year, sorry. You know what I mean? Some people did it last semester. I'm assuming that most of us did it last semester. Okay, I'm going to throw an example on the board. I'm going to do an easy one to harder. What example up to 5? I'm going to do an easy one, then you guys are going to do a hard one, then I'll pause the video. Okay, so let's see how we can do this here. So it says log y equals log 10 to the 1.25 equals log 10 to the 80. Now I know what you're thinking. You're saying, Mr. Salver, I have to use my calculator for this question. And the answer is shame on you, you don't. Okay? What's the power? This is a 2-step question, we're done. What's the first rule going to be? Luke Chase, I'm picking on you. When you're adding logarithms, what do we do?
Product.
Good. So what's 1.25? So it's going to change to log of 10. 1.25 times 80. Luke, using the calculator in your brain or on your paper, what is log 1.25 times 80, please? It was 1.25 times 80, not log. 100, good. Okay, so I'm going to show you the way I would solve this when I was in university. Okay, in order to get things to cancel out, what are you going to change 100 into? Just we.
10 squared.
10 squared, instantly, okay? So it's going to be y equals... Okay. Why did I want to do that? Yeah, okay, so the 2 is going to come down here. So it's going to be 2 equals y equals 2 times log 10 to the 10 with y equals 2. And calculus is beautiful. Okay? All right, I'm going to throw example 6, which is a little bit more interesting than this one. And then you guys are going to do it while I pause the video. Now, Luke, instead of playing with your phone, I think you can hide from me back there. You can't. Instead of playing with your phone right now, you should be doing this example 6. Okay, I'll give you guys a life lesson once I do this here. Log 3 to the x equals 1/2. All right, can I give you guys a life lesson? Too bad it's happening. You have to listen to me, tell your teacher. Let me hit pause on this video and then I'll give you a life lesson. You need